Payne.
Okay, yes.
Is it okay if I leave like 10 minutes early today? I have an orthodontist appointment.
You've got to do what you've got to do, absolutely.
Thank
And then you can watch the last 10 minutes after your meeting, no problem. Okay, so in the beginning here, remember, I'm going to do the camera. And anytime you need something like that, if you've got to go to the bathroom, go to the bathroom. If you've got to go to a doctor's appointment, go. You don't have to ask me. Thank you for letting me know, though, so I didn't think you just dropped off and got bored. Okay, so chapter 4, transformations. First thing we're going to do is talk about just like what kinds they are. So as you know, we have a translation is where you move it either horizontally or vertically. A rotation is where you spin things around a point. And then a reflection is where you flip things. So from front to back or up to down, or you can even flip it across a line, across a certain point. So when we're talking about reflections, the test here would be, there has to be a line of reflection. It has to be like a mirror, like you look in a mirror. So really, this would be your line of reflection. And then the test to see whether it is or not is if these were on paper and you folded the paper right here along this line, then every point that's on this outline would match every point on this outline. So I can see that this would not match here and this would not match here. So this answer is just a hard no. However, if I look at this one, and if this was on paper and I folded it like this matches that, this matches that, all the points match up. And so this is a yes. This does appear to be a reflection. You'll have to do a few of those. Okay? Again, any problems, pop your hand up and we'll be good. Now, this one I'm going to do 2 different colors. And the first thing I'm going to do, it says reflect the figure with these vertices across the given line. Now, this given line is the y-axis, and I sometimes get distracted and I forget where I'm reflecting over. So I'm going to actually highlight the y-axis here so that I know what I'm doing, because there's actually 2 different ways to do this. You can just look at the rule that we talked about and go from there, or you can count manually across this line. So first, let me write the rule down since this is review. So whatever you have as an XY, if you got something over, so you have something over here and you're going to flip it over here. You've got some picture and you flip it over here. Your y's stay the same. If it's this high, it's still going to be the same. But your x's are going to go from positive to negative. So the rule is that your x changes sign and the y stays the same. Meaning if I have m, then m prime is going to be a -2, +4. And n prime is going to be -4, +2. And p prime will be -3, -2. So I've now got my new shape. What I'm going to do first is draw MNP, and then I'll do my other shape in a different color, just to make sure I got it. So this is 2, 4, that'll be M. N is 4, 2, and P is 3, -2. And P, if you're not great with straight lines, then use a straight edge. I always have my straight edge ready to go, even like a little card, your ID card. Okay, so there's the original. And now we're going to graph the translation. Sorry, the reflection. Okay, so it's going to be -2, +4. -4, +2. -3, -2. So that's the new one. Of course, I'll use a different pen. This pen is so, and you can see it just looks like it was here and it got flipped over. And that is too fat for it. This one maybe. This one's dying, it's gonna go away. Okay. The other thing you could do, I said there was 2 different ways to do it. You could just count, okay, horizontally and vertically speaking. If you know that this is 2 away from the yellow line, then over here, your point over here is going to be 2 away from the yellow line. If you know this one is 4 from the yellow line, then this one's going to be 1, 2, 3, 4 over here from the yellow line. This one here, if it's 3 from the yellow line, it's going to be exactly 3 on the opposite side, 3 from the yellow line. So you can actually do it that way if you want, but you should be able to do both. Name the rule, figure out the points according to the rule, and graph. These will definitely be on there. Okay, B. Now I have a quadrilateral because I can see 4 points, but I'm doing the x-axis. So now I'm going to flip it this way. Should be able to do the same thing before, but now if I flip it this way, let's just review our rule. So if I'm here and I move something down, my x value will stay the same from here to here, but my y's will go from positive to negative. So x stays the same, y goes to negative. And that's why I don't have to memorize a ton of things. I just realize this is what's happening, so I can write the rule. So then here's t, u, v, w. -4, 1 is t. U is -3, 4. V is 2, 3. And W is 0, 1. So I'll basically have one that looks like down here if I get the points right. Okay, so T prime, U prime, V prime, W prime. Again, the X is going to stay the same. The Y is going to switch signs. The X stays the same. The Y switches signs. The X stays the same. The Y switches signs. The X stays the same. The W switches signs. Okay, so I'm going to try to do it in this color. So I've got -4, -1. -3, -4 is right there. 2, -3 is right there. And 0, -1 is right there. Of course, again, you won't be drawing with a pen or a pencil, you'll be drawing with Desmos on your final. But they do look like an exact reflection of each other, and you should be able to apply the rule. Any questions? Still going to keep checking. This one's slightly different because you can't just straight on count like these. So this will be easier even easier if you use the rule. And before I do anything, again, I'm going to highlight that line. And y equals x is 1, 1, 2, 2, 3, 3, all the way up to here to 5, 5. So y equals x actually looks like this, straight up the middle. And these are so fat, that's not going to matter. That's why otherwise I'd be using my straight edge. Now, when you swap this, the only thing you're really doing is you start with your xy, and then you're swapping. You go to yx. No, that's not right. Yeah, it is. You just go to xy, right? Because we're flipping over this, so we're switching our y equals x. Yeah. Okay. So if A is negative 2, 4, then A prime is 4, negative 2. B is 1, 1. So B prime is 1, 1. And C prime is going to be negative 1, negative 5. So if I do the first one at negative 2, 4, 1, 1, and negative 5, 1, then I want these to go here. Something's wrong. I did something wrong. This shouldn't be 1, 1. Should it? B is 1, 1. Where did I didn't, I did negative 1, 1. Okay, so the problem was not in the rule, the problem was with my execution here. Because 1, 1 is right here. Negative 2, 4. And then negative 5. Okay, now I feel good about this. So this is ABC. And then we're going to graph these 3 points. Because this way, you can't, it's not vertical and horizontal. You can't really count the way we did on these. Okay, you can't just count 1 down, 1 down.
Miss Payne.
Yeah.
For the points for C, it's negative 5, negative 1. I think you put positive 1.
Here? I haven't drawn it yet.
No, for the other one. For the original points.
Oh. Negative 5, negative 1. Thank you. Well, I'm not on my A game right now, am I? This is B for sure. A is negative 2, 4. And then C is negative 5, negative 1. You're so right. I hate to say this, but who was that? Because I wasn't looking.
Shira.
All right, Shira, extra credit for you. Thank you. Woo! You know, I would say I hate to make mistakes, but I don't hate it. I'm embarrassed. I don't like it. I don't hate it. All right, let's see if I can get these correct. So, but see, everybody makes mistakes. That's what I want you all to know. All right, 4, negative 2 is going to be here. That'll be A prime. B prime is right on 1, 1. And then C is negative 1, negative 1, negative 5, which will be here. Okay, that looks okay. That does look like a reflection. And these are kind of fat, so, you know, like it looks better when I did it earlier with just a pen, and it does look more precise. Okay, so I'm just going to say there's my more precise pictures. They look a little better. All right. Number 58, we're moving on. These are tell which transformations appeared to be a translation. So a translation just moves it either sideways, up and down, or a combination of both, which means that all you have to do is say, do they look the same size and shape? Do they look like they just got moved? And it doesn't matter if you go from here to here or here to here. This one looks like it's been moved up and over. Yes, it is a translation. These are not the same shape. So this is no. That's it. Tell whether they are or they aren't. You know, that's the positive about having lots of time to take a final that's only 35 questions. Got lots of time, but still there's going to be some easy ones. So you can go back and forth. So here we are on number 39. Again, we've got lots more graphing here. So now we're going to translate. So we have to remember what some of our vocabulary is, what some of our notation is. Translate just means move it sideways or up and down. Here is our notation. So if we have those chevron looking signs like that, what that means is x plus 0, y plus 3. And if they were minus, right? So this means you're not going to move it at all in the x direction, and that means y plus 3. That's x plus 0, and that's y plus 3. So all you're doing here then is I'll put my, here's my E. So let's just start with graphing it. -2, -4 is going to be E. 3, 0 is going to be F. And G is 3, -4. There's G. Okay, so we have our original. Now I'm going to actually write the points down of the new one, even though I could just raise them all 3. That would be the thing you want to do, but I want to make sure that you know how to apply this rule, which means our 3 new points are the same x, because it's x plus 0, -2, 3, and 3. Those will be our same x's, but our y's are going to be 3 higher. So -4 plus 3 is -1, 0 plus 3 is 3, and -4 plus 3 is -1, which means now I can do my other color here for the second one and translate -2, -1 is E prime. 3, 3 is F prime, and then 3, -1 is G prime, and for sure, when you connect it, it does look like a translation 3 up. So you should be able to do all aspects of that. You might get the picture and you have to name the points. You might get the picture and you have to write it in that notation. You might get the notation and have to write the rule. And so it would be x plus 0 and y plus 3. There's all kinds of ways to ask that question, but it's all one concept. Questions? Okay. So I'm just going to go along pretty quickly on this one. Let me check my time. 11:48. Okay, I think I'm okay. So A is 1, -2. B is 1, 0. C is 3, 1. D is 4, -3. Now again, you wouldn't have to write out all the points. You could just take each one of these and count them out, right? This means x minus 5, and this means y plus 3. So you could technically just go from A, go 5 left and 3 up, and put A prime. From B, 5 left, 3 up, put B prime. C, 5 left, 3 up, put C prime. D, same thing. You could do that. I just like to write the points because for me it's easier. But if I do A prime, B prime, C prime, D prime, you know I'm going to get 4 points here. So 1 minus 5 is -4, and -2 plus 3 is 1. For B prime, it's 1 minus 5, 0 plus 3. For C, it's 3 minus 5, and 1 plus 3, and 4 minus 5, and -3 plus 3, so that'll be 0. So let's see, let me try to do this with orange. -4, 1 is there. -4, 3 is there. Of course, I would be marking these too. -2, 4 is here. And -1, 0 is here. And yes, that actually does look like exactly the same shape. I'm just, you know, since I have fat markers, it's not perfect. But on your paper, it should look perfect. 5 left, 3 up. Okay. Questions? Stopping for questions quick. Okay. Again, same concept. You should be able to do any one of those questions. Tell whether each transformation appears to be a rotation. Now this is where it always has to be around a center point of rotation. That's one thing you have to remember. So if you have a central point, for here it would be in the middle here, and for here it'd be in the middle here, where they're connected. And a rotation is a rotation if you can, remember, if you put something there, so you put your point there, usually I like to just put my pen or pencil there. And then what you could do is just rotate your paper. If you can rotate your paper and get it back into that same spot, somehow less than ideally 180, right? Because every once in a while it's 270, but if you can get it to look the same without being at 360, then it's a rotation. So if I'm here and I rotate it here, well, obviously it doesn't look the same. And I rotate it here, it doesn't look the same either, because these triangles are up, and where I started, the triangles were down. So this one is not a rotation. It's a reflection for sure, but it's not a rotation. Now this one, it's slightly like stretched here, but they're supposed to look exactly the same. But if you had your pen right here and you twisted it around, then yes, it would actually look the same at, say, 180. So this is a rotation. The same shape, you just have to rotate it around that point. And these are all eyeballies. You know, you're just sort of looking at it. There's not a lot of work on, there's no work on that. There'll be work when I ask you for symmetry lines, but not this one. Okay, now rotation was the hardest for everybody. It always is, because there's these different like rules involved. So we're going to write down each rule with rotations. The first one being, it says rotate the figure with the given vertices about the origin. Okay, so we're doing 90 degrees here. If it doesn't say clockwise, then we are assuming that it is always counterclockwise. And that means 90 degrees is one quadrant. And I'm always drawing arrows, because if I don't draw arrows, sometimes I go the wrong direction. But if you'll notice down here, it says 90 degrees clockwise. So from wherever you are, you're going to be going this way. You'll be moving this way in the next quadrant. So if it doesn't say anything, remember it's counterclockwise, and sometimes you'll see the definition counterclockwise. That's what CCW means. Again, this one is also 180, but when you do 180, it doesn't matter whether it's clockwise or counterclockwise, because no matter which way you go, you're going to end up two quadrants. So if you start here, you'll end up here counterclockwise. And if you start here, you'll end up here clockwise. So that one, you know, doesn't really matter. They're both the same. Now, here's for the rules. First rule we'll do for 180, because that's the easiest. Okay, you're going to take whatever xy you have. And so say if I have both positive xy's and I end up down here, they're the same numbers. You just switch the signs. Okay, so they both go from positive, positive to negative, negative. It's not the same as a 90 degree or a clockwise. So first of all, 90 degrees counterclockwise is equivalent to 270 degrees clockwise. So you can do 2 with this one rule. And similarly, write this down on your paper. This 90 degrees clockwise is equivalent to 270 counterclockwise. So that means as long as you're only learning a couple of rules, this gives you both directions, this gives you both directions, and this gives you both directions. You're covered with only 3 rules. So what we're going to do for both, we already got that rule, but for both of these, the rule is like this. You're going to swap your X and your Y. Okay, so your Y goes here and your X goes here. Your Y goes here and your X goes here. The way I remember the rule is if I was here to start with, and then I ended up here, which coordinate is negative? It's my first one. My X coordinate will be negative. So the negative goes here. And then for this one, same thing. If I'm here and I go down 1 quadrant, now my Y coordinate is negative. So this one's going to be the -1. See how I remember those? Your X will be negative and your Y will be positive. Your X will be positive, your X will be negative, but you're going to swap your X and your Y. And those are the 3 rules. Okay? If you have these 3 rules in front of you, you'll be golden. So let's go ahead and write, well, first we'll graph RST. Here's 0, 0, that's R. 3, 1, that's S, ET is 2, 4. And we're going to rotate it so it's in this quadrant. First, let's write the coordinates out. Okay, so I'm going to take R, which is 0, 0, and I'm going to swap them and make them negative. So R prime is also 0, 0. I'm going to take 3, 1, I'm going to swap them, so the 1 goes here and the 3 goes here, but the first one's negative because now I'm in the second quadrant. 2, 4, I swap them, make this one negative. So now I should be able to graph the new one. Okay, R goes here, R prime, S prime is -1, +3, and T prime is -4, +2. There you go. And that's, of course, you can always like pick this up and go, okay, if I go 90 degrees, yeah, that looks like what I started with. Okay, so now we're going to do the next one. So 0, 3 is E. 3, 5 is F. And 4, 0 is G. Now, in order to apply the rule, which means you can go either direction, all you have to do is switch the signs. So E prime is 0, -3. F prime is -3, -5. And G prime is -4, 0. So again, I'm going to use a different color. Let's see if this one works. Okay, so I've got 0, -3 for E prime. I've got -3, -5. Nope, I'm 1 off. 5. Yeah. For F prime. And for G, I've got -4, 0, which is right there. And even though this is a little fat, that does look like the same thing, rotated 180 degrees. Okay, repeat the process. U is 1, -1. V is 4, -2. W is 3, -4. So I've got this little triangle, and I'm going 90 degrees clockwise, which means I'm going to go from here over to here. So another thing, if you do these points, you should just recognize this is going to put you in the third quadrant. So all your points should be negative if you followed the rule correctly, which means since I got a little space over here, I'll do U prime, V prime, W prime. Okay, so U is 1, -1. I'm going to swap them, which puts the -1 here, and then it takes that 1 and makes it negative. These I'm going to swap, so -2 goes here, and then the 4 turns negative. The -4 goes to the front for W, and then the 3 turns negative. So look, I have all quadrant 3 points. Yay, that's a good sign. And then I can graph them. -1, -1 goes here. -2, -4 goes here. And -4, -3, 1, 2, 3 goes there. So it's all good. Of course, I'd be labeling them in the interest of time. So there we go. We've got all 3 rules. We've applied it for the points. You should remember the nomenclature for clockwise, counterclockwise, which ones are equal. Okay, that's the review for that one. Now we got a couple more because we need to do rotations and a combination of things. So the next type of problem is once you did your reflections, your rotations, and your translations, then we started combining them. So you remember that? This one is going to have 2 movements. First, we're going to rotate, and then we will reflect. So again, it's not like too difficult. Let me just check the time to make sure. All right. I am going to I probably won't have time to do all of these, but I definitely want to do 64 and 65, and we'll come back to this if we have time, so that's your assignment with, of course, you're starting on chapter 5 too. So first of all, tell whether each figure has line symmetry. So line symmetry is where you can fold the paper. Okay, so it means if you have something where some line that goes through a vertex, for this one, the only way I can see, if this was a piece of paper, the only way I can see to match up both sides would be through this line in the middle. So yes, it does have line symmetry, but that's it, just that one line. This one, line symmetry has to be where if you fold the paper, everything would match up, but this doesn't because of this little chunk out here. You can't go this way or this way or this way or this way. So this does not have a line of symmetry. However, there's a second kind called rotational, and there is a rule that goes with this. Rotational symmetry more has to do with the number of vertices. Okay, so rotational symmetry has to have a center point from which you can rotate it. I'm going to start with this one because it's easier. And it says, if it does have rotational symmetry, what is the smallest angle of rotational symmetry? So if you have something with a lot of vertices, you can just turn it a little bit and it will be the same. This one has 4 vertices, which you can't see them, but it's here, 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 and here. Like if this was sort of a box and I had my pen right here around my center, then I could move it 90 degrees and it looks like the same picture. I could move it another 90 degrees and it looks like the same picture. 90 degrees, it looks like the same picture. And 90 degrees, it looks like the same picture. Now, the reason I knew it was 90 degrees is because I took that 4 and I divided it into 360. So the number of vertices, okay, a number of lines of symmetry. So there's 1, 2, 3, 4 lines of symmetry here. That means that every 90 degrees, you'll have rotational symmetry. This one, though, does not have 4 lines of symmetry. It only has 2. Okay, so it's, you can divide the line of symmetry this way, but that means that the only rotational symmetry is at 180 degrees. So you could turn it this way 180, you'll get your same image, and then if you do it again, another 180, it means twice, then this is 180 and this one. They both have rotational symmetry because you can spin them around and they look exactly the same at this degree. But like if I wanted to know all the degrees, that it'd be 90, 180, 270, and 360 if it asked you for those 4. Any questions? That was the last thing we went over, was rotational symmetry. Now let's get back to these, and hopefully we'll be able to finish at least one. Okay, so what you're going to do is do 2 rules, right? The first rule, you'll start with these. A is 0, 1. Sorry, 0, negative 1 is A. B is 3, 4. And C is 3, 1. So for each one of these, what I would do is I'd write the rule first. So my rotation rule for 180, all that does is change the signs. That'll be that one. But then if I reflect it across the X, the second rotation, okay, so you're going to reflect. That rule is you're going to take these and you're going to change them to, remember, if I'm going across the X, it's going, the Y's are the ones that are changing. So my X will stay the same and my Y will change. So A prime, okay, I'm starting with 0, negative 1. Then A prime, the 0 will change to 0, negative, which doesn't change. And the negative 1 changes to a positive 1. And I'll do B. B is 3, 4, so it turns into negative 3, negative 4. And then C prime will be negative 3, negative 1. Now I'm going to apply this with these as my first XYs. So now I'm going to go to A double prime, B double prime, C double prime. So I start with my original XY, which is here, XY, and all that's going to change is the Y goes negative. So it's going to be 0, negative 1. It's going to be negative 3, positive 4. It's going to be negative 3, positive 1. That's how it changes. And then this is what you're going to graph. The second one that you're going to graph will, of course, be this one. So then A double prime is 0, negative 1, negative 3, 4 is B double prime, and negative 3, 1 is C. So that's what it looks like after you rotate and reflect. So it like rotated here and then it reflected back. Okay, so we got almost all of them done. This is the same type, but it's a reflection and a translation, which is actually a little easier. Just remember this vector actually says X plus 1, Y plus 3. And so so you do the reflect across the X, which changes your, across the Y, which changes your X's, and then translating, you're adding in. Didn't quite get that time. I think that's good enough. Okay, for all of us, and I'm looking at you now. I don't want to keep you extra. It is 12:10. And so let me stop my recording. And if you have an extra question, stay back. Otherwise, you're just